So good afternoon everybody, myself Acharya Vishvendra. Let's discuss some worksheets on circular motion. So let's start with things. So suppose there is a circle having center C, radius R, and a particle is moving along its periphery with a speed v. So the first question is centripetal acceleration, magnitude only. So that is equal to v square by r. Next on, now we have some graphical variations of centripetal acceleration with different parameters. So the first question is a graph between acceleration and speed. So centripetal acceleration is proportional to v square. That means graph is a parabolic graph. If we assume that radius is constant, so it will be a parabola turning toward the axis of AC. Next question is, if v is constant, that is speed is constant, so acceleration centripetal proportional to 1 by r. That means graph will be a rectangular hyperbola. In next question we have centripetal acceleration and 1 by r. So we take 1 by r as x. So we can say that AC is proportional to x. So that makes the graph a straight line. Next is, if we draw graph between centripetal acceleration and v square. So we assume that v square is x. So AC is proportional to x. So the graph will be a straight line. Next one, now we have a vector problem. Suppose this is the xy plane. There is a particle moving with a speed v. So this is direction of centripetal acceleration. This is the tangential acceleration. We assume that its speed is increasing, so that velocity and tangential acceleration are parallel. So now the question is centripetal acceleration is. So we know that it's v square by r, and since it is directed toward the center, so I have used minus r cap over here. In terms of vector, it can be written as minus v square by r square into vector r. As unit vector is vector r by r, so that r is going to be multiplied with this. So we have this as the expression for the centripetal acceleration. Next is tangential acceleration. So tangential acceleration is dv by dt into v cap. Next is total acceleration. It is the vector sum of centripetal and tangential acceleration, like this we can draw. Next is magnitude of total acceleration. So we have seen that these two vectors are perpendicular. So the hypotenuse is going to be the total acceleration magnitude, which is root 80 square plus AC square. Then we need to find tan alpha, which is 80 by AC. So alpha is tan inverse of 80 by AC. Next, so now we are being given a question. A particle is moving on a circular track, which is given in the first quadrant itself with a speed 10 meter per second, which is given to be constant, and at a certain instant it's at an angle of 37 degree. Radius is given to be 4. So the first thing is centripetal acceleration in terms of magnitude is v square by r. So solving this, we have 25 meter per second square. Next on, now we need to find acceleration centripetal in vectors form. So we can see that centripetal acceleration will be directed toward the center over here. Let us say this is the center. So this angle is going to be 37. So if we extend this vector, this angle is 37. So its projection along the x-axis will be AC cos 37. Along the y-axis AC sin 37. So if I write this vector, we can say that this is AC cos 37, and this corresponds to negative y direction with a unit vector minus j cap, and this corresponds to minus x-axis corresponded by minus I cap. So if we calculate the values, centripetal acceleration finally comes out to be minus 20 I cap, minus 15 j cap. Next one, now we need to find the tangential acceleration, which is dv by dt into v cap, where v is the speed. Since speed is constant, which means dv by dt is 0, that corresponds to tangential acceleration as 0. So these are the basic worksheets developed especially to help the students who are not comfortable with physics, and in spite of their best efforts, they are not able to score good in physics. So these worksheets are especially designed to make sure that you are very clear with the fundamentals, the basic terms, the basic concepts, the basic graphs, and are able to use them when solving higher thinking order questions. I shall soon be uploading the higher thinking order question worksheets soon. So you can, if you have any comments or any query, you can drop your comments on the YouTube section. Thank you and have a nice day.